Woohoo! We are live, and this is Fractions Bite. A little bite of fractions for your day. The problem with parentheses. Ooh. Okay, so what are we talking about here? Well, what we're talking about here is the fact that sometimes when you're dealing with fractions, you don't just have simple terms, you have parentheses in the middle of an equation. So what the heck are you supposed to do? So let's take a look at this problem. Ooh, I'll bonk everything just to make it more fun. This is a fairly complicated equation. It is linear, which means the x's are just x's. There aren't x squared, x in the denominator, no square roots of x or radical x, nothing interesting like that. It's simple x's. So this is a linear equation. And in fact, it has one variable, just x, so that makes it nice and simple. Again, not easy, but simple. And I've got fractions. Now, could I keep the fractions and just solve it? Absolutely. If you just want to solve it because you love your fractions, or you don't have the energy to get rid of them, you're not even going to bother, go for it. This video is going to talk about what to do if you've decided you want to get rid of them. So if we're going to clear the fractions, to clear the fractions, and that's what we call it when you multiply everything by a number, I'm going to need to find the LCD, or some people consider it the LCM. They're not the same thing, but they both speak to the same process. Least common denominator or least common multiple. And basically what we're going to do is we need a mega number, much like Godzilla, that can go through and stomp all of the fractions out of existence. Blah, ha, ha, ha. So if I take a look here, let me get my handy dandy. Oh, that's exciting. Other notes for other math. Don't you hate it when other math is trying to get in on your math videos? I'm going to take a look at my two denominators. Now, technically, you can look at whole numbers or integers as having denominators, but their denominators are 1, so we don't have to worry about them. They don't appear as fractions, so they're not going to bug us. So what I want to look for are all the denominators that aren't 1, the denominators that are in the way, the 2 and the 3. Now, this case, which I picked because it was fairly simple, again, not easy, simple, the LCD, if I'm looking at the numbers 2 and 3, I'm thinking, what multiple, what larger number, what Godzilla number, rah, 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 is big enough to include both of those? Now, here's the hint. A lot of times, the easiest thing to do is just multiply them. And in fact, multiplying in this case is perfect. So if we're looking at 2 and 3, our LCD is going to be 6. I just multiply 2 times 3. Or 3 times 2. So 6 is going to be our least common denominator or least common multiple of the denominators. And what we're going to do is we're going to give everyone a 6. So I'm going to, you know how I love rewriting problems. So let me rewrite it. So I've got a new version right here. Now here's the thing. We've got to, I'm so sorry to the person who's captioning this. I have no idea how to caption what I just said. But what we need to do is we want to maintain balance and maintain fairness to maintain the equality here. So we got to multiply everybody by 6. But this gets complicated because, for example, I can see that the 3 is sitting here by itself. Okay, I know I need to multiply that by 6. But what about this mess in here? And here's the answer. You need to figure out which are the terms. Oh, that made perfect sense. Which of these things are terms? So what I want to look for is I want to look for a plus or a minus. That's what separates terms. So this is a term right there. This is a term over here. That plus means that the 3 is a separate term. And then now here I see a plus, but you see how it's held inside of the parentheses? It is held together. So these two, although they are separate terms inside of that set of parentheses, in the larger picture, this actually counts as one term. That's what these parentheses do. They smash it all together. So this giant mega term is still just a term. So let's take a look at what I should do with my 6. So I've got, let's see if I can alternate. I'm going to go ahead and remember that 6 is also equal to 6 over 1. I can write it either way. And what I'm going to do is for each term, I'm going to decide, do I need to write it as a 6 or do I need to write it as a 6 over 1, which will be the easier version. So for this first term, I'm going to multiply, since it's a fraction, I'm going to multiply by 6 over 1. Now, personally, I'm going to take this minus and write it here. There are different styles. Your style may be that you write a plus here and then include the minus inside with the rest of the term. It's up to you. I learned to do these signs in the middle like that. This is a big old mess, but what's on the outside is a fraction. So I'm going to write my 6 in fractional form. Now over here, this leading minus, you can write first, or since it's the first thing that occurs over here on the right. I know here I put the minus in the middle, but here everybody learns these interesting little details. I learned to snug it up. So since this is not in fractional form, I'm going to write a whole number, and then I'm going to do this. Now, if you think that's awful, can you do it a different way? Absolutely. Anyone who tells you that algebra only has one possible way is not telling you the truth. Let's be honest. Now, the plus 3, I do a plus, and then I do 6 times 3. So let's take a look. I've got 1, 2, 3, 4. So there are 4 terms. I wish I had my count right here. My count puppet would be going, eh, 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 eh. Oh no, that's terrible. That sounded like a cat throwing up. 4 terms. There we go. Okay, so, what? I didn't just write that with red. There we go. So I have 4 terms. So I have 1, 2, 3, 4 6s. Each term gets a 6. Now, I can tell that you're already worried about this mess. Let's not worry about this right now. In fact, when you've got an equation and you're clearing fractions, you can start with the right-hand side if it's easier. So let's start there. 6 times negative 2x, sorry, buddy hair, is negative 12x. 6 times 3 is 18. Woohoo! Always give your brain a little bit of success. If it's feeling stressed out, do something that can be successful about. Brains get sad and tired too, so give them a chance and be like, yay, brain, you're so smart. And your brain's like, yay, I'm so smart. Because your brain is very smart. Math is just really hard sometimes. Okay, so over here, the messy side, with our mega number, which is going to smash all the denominators, much like Godzilla, I can cancel this 2. This is the whole point of clearing fractions, and it cancels with 3. And then this 3 cancels with the 6 and becomes 2. So here I'm going to rewrite this. 3 times 3x minus 2 times, this becomes 1, 6x plus 9. Now, at this point, I could hear a lot of people saying, wait a minute, this doesn't seem balanced to me. What about the stuff on the inside? How are they going to get their 6? I mean, this doesn't seem fair. Everyone else gets a 6 and they don't get a 6. And here's what I'm going to say to you. This is the amazing thing, the miraculous thing about the distributive property. and that is that this used to be a 1/3, which was supposed to multiply all the way through. But what we did was we took the 6 and the 1/3, we combined them, they became a 2. So 6 times 1/3 is 2, and that 2, and it's actually because of the minus, it's a -2, that is going to carry the 6, which is hidden inside of it. It's like a spy. It's like numbers in a trench coat sneaking into a theater. This is the 6 and the 1/3 combined, both multiplying. So the 6x and the 9 are getting their 6. It's just kind of, it's harder to see. Okay, let's see. I get 9x over here, and then minus 12x, right? That's 2 times 6x with the minus, and the minus 2 times 9 is minus 18. And that all equals negative 12x plus 18. Now we can stop here for a moment and talk about the fact that, wow, all of this work was to avoid working with fractions. So is there a good reason to get good at fractions and just skip this mess? Sure. You could just, if you feel comfortable working with fractions, you could just distribute this one negative 1/3 and then solve the problem. The thing is, a lot of people just struggle with fractions, and it makes it a lot harder to get through. So is it worth it to do all this work to clear the fractions? I would say most of the time for most people, absolutely. Okay, let's combine like terms. Let's see, I got a, this is a mess. I got a negative 3x minus 18 equals negative 12x plus 18. Now here's where you want to be really, really, really careful while I go to get my another piece of paper. So why do you need to be really, really careful? Well, again, we're going to thank our brains. We're going to say, brain, you are amazing. And you have consistently saved me from being eaten by saber-toothed tigers. So I'm going to assume no one watching this video currently was eaten by a saber-toothed tiger. So your brain has done you an amazing favor, kept you safe. The problem is that your brain is also going to jump to conclusions. For example, it's going to see these 18s and go, oh, they cancel. They're both 18. And you got to say, thank you, brain, but let's look. There's a plus 18 and a minus 18. So I want to be real careful with that. Your brain is going to, jump to these conclusions, and you just think it and say, yep, we just need to move a little bit more slowly. Your brain is trying to save you from the math. And I'm here to encourage you to spend some time with the math. Don't rush through it. It's okay. Can't hurt you. Literally, it can't hurt you. It can stress you out, and you could hurt you. You could get all frustrated and not sleep. Yeah. Or you could just say, you know what? It's just math. It's just math. It's fine. In fact, if I wanted to, I could write this equation down and then crumple up this paper, go outside, get some exercise, breathe some air. Math. What math, right? Okay, so here's where we stand. Okay. So even though there are no fractions, I still have to make some decisions. Like, I personally always choose where the x's go first. And I'm going to say, you know what? I'm just going to put the x's on the left. So if I want to move my x's over to the left, I'm not really moving them. I have to do the same thing to both sides. So what I'm going to do is I'm going to add 12x, which is going to cancel this. I can add anything I want to both sides. I could add 42x. Wouldn't help, but I could. If you're just like, if you're at a math party and you're like, hey guys, let's add 100x to both sides. Then everyone's like, yay, let's do it, yay. Math parties. They get a little bit like that, huh? Right? Okay, negative 3x plus 12x is 9x minus 18. And then over here, I've got that plus 18. My brain is still trying to get me to cancel. And I'm like, whoa, hold on, brain. What do we do to both sides to quote unquote move this? Well, what I do is I choose to add 18. And that's going to cancel that here. But in order to add 18 on the left, got to add 18 on the right. And then I get 9x equals, and then I get 36. This is zeroed out. And then my last step is to divide by 9. Again, both sides. Remember, we got to work on balance. You got to be fair. You got to be balanced. Truly fair and balanced. Woohoo. X equals 4. So to keep this video short, I'm not going to show the check. In order to check the problem, we would in fact have to go back and use the original. You always check with the original. And that would probably take us another 5 minutes. And I'm trying to keep this video short. But feel free to ask me, how do you check this? I'd be happy to do that. So just ask any questions if you have them. Otherwise, woohoo, we made it through multiplying, even though there are parentheses. Woo! Yay! Dance party time. Okay, math on, everybody. Woohoo.